Hello, welcome to Physics Explained, where we crack the code of nature. Let's dive into today's problem. So, there is a rod that revolves with a constant angular velocity omega. It's the rod, okay, that revolves around a constant angular velocity omega around a vertical axis A. The rod includes a fixed angle of pi by 2 minus alpha with the axis. Okay, so from this horizontal axis, this is alpha. A body of mass m can glide along the rod. The coefficient of friction is mu equal to tan beta. The beta is called friction angle. Determine the angles alpha under which the body remains at rest and under which the body is in motion. The rod is not rotating. If I omega equal to 0. The rod rotates with constant angular velocity omega greater than 0. The angle alpha does not change during rotation. Find the condition for the body to remain at rest related to the rod. So let's start. First we solve the A part when the rod is not rotating. The rod is not rotating. This is similar to like an inclined question, right? So this is the A part. Here is a rod. This angle is alpha. This is our body of mass m which can glide through this. Okay, and this distance is given as L, right? So let's draw the ABD of the mass. ABD of mass. So here is mass m. Similar to incline. This angle is alpha. This is the mg. And omega equal to 0. In this case, the rod is not rotating. That's a pretty similar to incline. M equal to mg. There will be a normal like this. Mg along this inclined component will be mg sine alpha. This component will be mg cos alpha perpendicular to this. And this is friction, right? As mg sine theta is acting downward the incline, friction will oppose that. This friction is static friction. We are searching the case when this is at rest, right? So the friction is static friction. So n equals mg cos alpha. So what is the maximum value of friction? Mu is given as tan beta. Is tan beta. So F max, F static max is basically mu into n. So tan beta mg cos alpha, right? So see, yes, see in this case, if the maximum value of friction is 10 Newton, if we apply 1 Newton, maximum value of static friction, we apply 1 Newton, the friction will act as magnitude 1 Newton, not as 10 Newton, because static friction is self-adjusting until we do not apply force till the maximum value of friction. It will adjust with the applied forces value. So to rest for this scenario, what we can write? F must be less than equal to Fs max. Similarly here, what is F which will move the body towards downward? This is mg sin alpha. So mg sin alpha should be less than equal to fs max. So mg sin alpha fs max is tan beta mg cos alpha. Mg get cancels. So tan alpha should be less than equal to tan beta. So alpha should be less than equal to beta. If alpha is less than equal to beta, the body will be at rest. Will be at rest. If alpha is greater than beta, the body will move, start to move. Okay. You can find this in another way. Because I said it is similar to something like wedge. You must have heard the think the angle friction or angle of force. I forgot the term. Let's, it is said that beta is the angle of friction, right? Friction. Suppose I alpha equal to 0. This angle is 0. As I increase alpha, you must have heard. This is, I think, the definition of this. Till alpha equal to beta, in all cases, alpha less than beta, the body will not, the friction will adjust. When alpha greater than beta, the body will start, right? So you can find this from this way also. So this is our first part. If alpha is less than equal to beta, body will be at rest. Alpha greater than beta, body will. Let's go for the B part. Now the rod rotates with constant angular velocity omega, and alpha doesn't change. So here is the B part. This is the rod. This is the angle alpha. Here is the mass m. This length is L. This is the axis at which it rotates with omega, right? So what the angle alpha definition? Find the condition for the body to remain at rest relative to the rod. Relative to the rod. So we have to go in the rod frame of reference, but there is a catch. What this distance is varying at. Suppose this so I as a radius because the rod will move something like this in the 3D way, a conical shape, right? So I am taking this as the radius of this circular part. So as the radius is changing, suppose I am in this point, I will have a centripetal acceleration r omega square towards this axis. So as the r is varying, this a centripetal will vary. So all if I sit in so many different places, so the centripetal acceleration will vary. In that frame of reference, I will apply the pseudo force because that is an accelerated. The pseudo force will be varying. This you have to understand. So I am taking as general. Suppose this is at r distance, and I am sitting in this position. It's general. R can be anything from this to this. So let's see. If I draw a BD of M from frame of reference of rod at a point, I'm sitting at the point at the distance r from the perpendicular distance, r from the axis. Sorry, perpendicular distance. But this distance is perpendicular to the x, not perpendicular to the rod. So this is m, this is mg, this is normal, this angle is alpha, which is not changing. And I am this person, right, which is at r. I have an centripetal acceleration towards left. So when I see this block, I'll give the pseudo force towards right. This is r omega square. So force will be mr omega square. Okay. So if I take the component, this will be mg sine alpha. This is mg cos alpha. Alpha. So this will be alpha. This is mr omega square cos alpha. This component will be mr omega square sine alpha. So see this. I can say normal equal to mg cos alpha plus mr omega square sine alpha. But there is a problem that I cannot say friction will act upward, where in case of omega equal to 0 it is acted in upward direction, but here I cannot say that friction will act as upward. This depends on the value difference between mg sin alpha and mr omega square cos alpha. So there will be two cases. Case 1, if mg sin alpha minus mr omega square cos alpha is greater than 0. What does it mean? This is n, this is mg sin alpha, this is mr omega square cos alpha. So this downward component is greater, so friction will act upward in this case. So maximum value of friction is same. This max is mu into n, where mu is tan beta. So I am now writing the cases, writing the condition, and to find the where this at which are the friction, the this driving force will be equal to maximum value of friction. Because if the driving force gets more than the Fs max, then it will start motion. I am finding condition for this. So I want to find in which radius the it equals to the Fs max. So let the radius be r1. So mg sin alpha minus m r1 omega square cos alpha. Fs max is basically tan beta. Normal is mg cos alpha plus mr omega square sin alpha. So mg sin alpha, I can write tan beta is sin beta cos beta and multiply cos beta with both sides. So mg sin alpha cos beta minus m r1 omega square cos alpha cos beta. Then sin beta will be multiplied on the right side. So mg cos alpha sin beta plus mr1 omega square sin alpha sin beta. Now taking this mg component this side and mr1 omega square this side. So mg sin alpha cos beta minus cos alpha sin beta equal to mr1 omega square cos alpha cos beta plus sin alpha sin beta. So mg sin alpha cos beta minus cos alpha sin beta is basically sin alpha minus beta. M r1 omega square cos alpha cos beta plus sin beta is basically cos alpha minus beta. M gets cancels. So R1 I got G by omega square tan alpha minus beta. Then case 2 where mg sin alpha minus mr omega square cos alpha less than 0. What does it mean? This is m. This is mg sin alpha. The this is mr omega square cos alpha. All this becomes because R can vary, so the pseudo force component will vary. So there is two cases. There will also another case mg sin alpha equal to mr omega square cos alpha where there is no need of friction. So you can calculate that also. You see, the upward component is greater than the downward component along the incline. So friction will act in downward direction. So similarly for extreme condition checking, mg sin alpha minus mr omega square cos alpha, as this is minus, to compare with values we have to put a minus here. So this would be the maximum value of friction, which is tan beta into mg cos alpha plus mr omega square sin alpha. Tan beta mg cos alpha plus, let this reduces r2 mr2 omega square sin alpha. So similarly, this I can write as sin beta cos beta, multiplying cos beta this side, sin beta this side. So in the cos beta in left hand side, sin beta right hand side. So this becomes n minus g sin alpha cos beta plus mr2 omega square cos alpha cos beta is mg sin beta cos alpha plus mr2 omega square sin alpha sin beta. Taking the mg component one side, mr omega square component this side. So mg sin alpha cos beta plus sin beta cos alpha equals mr2 omega square cos alpha cos beta minus sin alpha sin beta. And I'll get cancel. G sin alpha cos beta plus sin beta cos alpha is basically sin of alpha plus beta r2 omega square cos alpha cos beta minus sin alpha sin beta is cos alpha plus beta. So R2 is basically G by omega square tan of alpha plus beta. So what is the physical interpretation of these two radius? Suppose this is the rod, this is the radius R1, this is the radius R2, right? So suppose the box is at M at here or M at here. Here in R1, the mg component is greater than the pseudo force component, so friction acts upward with its maximum value. Here in R2, pseudo force component is more than the gravity component, weight component. So the friction acts downward with its maximum value. There is a place between these, which this is the R dash, which we can calculate that there is no need of friction. They will balance each other. So from this position, when it declines, the force will adjust the difference, and at our own position it gets maximum. From this R dash, when we move upward, the force self adjusts the difference between pseudo force and this, and at R2 the F acts downward with its maximum position. From R1 to R2, R1 to R2 distance, it is going to rest in the frame of reference of the rod, right? So you can write the frame of reference calculated from it will be in rest from R1 to R2. So, but there is two cases, right? Alpha can be greater than beta, or alpha can be less than equal to beta. So what if alpha is greater than beta? If alpha is greater than beta, tan of alpha plus beta is greater than tan of alpha minus beta. This quantity is positive. This quantity is positive. R2 is greater than R1. Both these guys are positive value. So this scenario will be for alpha greater than beta. R1 has some value positive, R2 has some value positive. In between R1 to R2, the block will be at rest. But for alpha less than equal to beta, tan alpha plus beta is greater than tan alpha minus beta. This is positive, but this side is negative. That means R1 is in negative, R2 is in positive. R1 in negative means this side. But as there is no rod in this direction, so R1 has minimum value. R1 is negative, but it we have to consider from 0. So for alpha less than equal to beta, if we place the block at any position between 0 to R2, it will be on rest. But here we are measuring the length, so you can calculate the length from L1 Li equal to Ri by cos alpha. Right? For R1 it will be L1 cos alpha, for R2 it will be L2 cos alpha. So this is the solution. I hope you understood well. If you have any question, write it down in the comment section. Let's meet in the next video.